speaking about equation. What is the definition of equation? So let's recall back about expression. Expression is another a sentence in mathematical language. It's the same with equation, but an equation is a mathematical statement that two things are equal. So if you have two phrases and you combine it in English language, it's the same with we have two expressions and we combine it with an equal sign. That is equation. So it consists of two expressions on one on each side of an equal sign. So this is the one of the example of an equation. Okay, it's taken from a website. You can see that there are many terminologies that we have to memorize. So these things are equation. So the left side or the left hand side, or we can say the left member, contains two terms, the first terms and one term. Okay, and the right hand side or right member contains a term. Okay, so this whole thing is an equation, this is an expression, and this one is a term. Okay, so it combines two uh, expressions into one equation with an equal sign. So this one is a coefficient, variables, and operations, as you can see on the picture. So let's recall back the previous terminologies that we have learned so far. Now the next one is, I will give you another example. How about what it's meant by equations that combine or two phrases or two expressions, for example, like this one. So we have, this is the first expression, okay, and this one is the second expression, okay, and they combined into one single long statement with an equal sign between them. So that is an equation. Of course, equation must involve equal sign. So how about the vocabularies? This is the new vocabularies for you. The first one is root. Root usually replace, or we can use it to replace solution. So it's the same meaning with solution. A solution, a root. And then solution set is a set that contains all possible solutions. So later we will speak a lot about solutions, but all the solutions that you have to put it into a solution set. Then we speaking about how you write the solution set, it must be like this. Okay, it begins with S, represent a solution set, equals, and all the solutions you have, all the solutions, all possible solutions must be put or written inside between braces. Okay, we use braces only for solution set, not brackets, not parentheses, especially not absolute sign. Okay, only braces. And then the next vocabulary is that you will read it on the textbook. I won't explain it a lot. An external solution is a number which satisfies a transform equation, but not the original equation. It's for in a simpler world, simpler word. An external solution is a solution that somehow it didn't exist on the original equation, but because you are doing some transformation to the equation, usually by multiplying both sides by variables, uh, a solution, a new solutions just pop up, just exists, which originally didn't. Okay, but we will speak about that later. So the irreversible step is the step that makes the solution, the external solution happens. It's when you multiply both members of an equation by an expression which can equal to zero. I will speak about this later. And the last one, but before we go to the example, the application, I want to give a different. What is the difference between expression and equations? If we are dealing with expressions, usually we only can do things, which is simplify the expression or evaluate. Again, for expressions, recall the previous material, you can only simplify it, or you are evaluating it by the given number to replace your variables. How about equation? Solving an equation means writing its solution set. Now, in the upcoming examples, I will show you what it means by solving an equation. Let me give you example. First, I'll give you example of expressions. Don't forget that this is an expression without equal sign. What you can do is only simplifying or evaluating. This is already been the simplest form. It means if you have to simplify it, you just cannot do anything with it. But if you need to evaluate it, for example, I give you replace x equals 7, evaluate it. So you just substitute x by 7 and then calculate it. It's 0. That's expression. How about equation? For example, this is equation. See the difference? There is an equal and there is another statement on the right member or on the right hand side. But for now, I will use member. This is the right member, this is the left member. Okay, it's connected by equal sign. So this one, how to solve the problem? Usually the objective is to find all possible solutions, all possible numbers to replace x to make this statement or these equations true. Okay, that is the objective. We solve x, we find all possible values of x. So for now, I suggest two alternatives. Okay, you can choose one. First, I will use factoring. Okay, this skill maybe is not necessary for this chapter. We will learn later, but I will introduce you if you have already mastered factoring. We factor completely the left member, this one. Okay, I can factor it. It becomes x plus 7 times x minus 7 equals 0. Okay, what is the objective? By factoring this, I can know that we have two factors, 1 and 2, which the product is 0. By referring to the multiplication property of 0, it means at least one of the factor will equal to 0 to make the product equal 0, right? Something times something becomes 0. It means one of the something must be 0. Okay, so this is the note. The only way to a product of two real numbers can equal 0 is for one of the factors to equal 0. So let's find all possible values of x which makes one of the factor equal 0. So for the first one, how if this one is 0? What is the possible value of x? So I will make it this statement. So the first candidate is x plus 7 from the first factor equals 0. So the first x will be equal to negative 7. I will explain about the operation later, but this is just introduction. Or how if the second factor equals 0? What is the possible value of x? So I will write it this way. The second factor, x minus 7, equals 0. What is the possible value of x? The possible value is 7. Yeah, you can. So 7 minus 7 equals 0. It's obviously. So we have two possible values for x for this equation, for this equation. Don't forget, not one. So solving x you must find as complete as it is, all possible values. You cannot just be satisfied by presenting one solution or two solutions if there is more. You need to present all. Okay, since we are sure that there are only two of this, so you can write down the solution set. Remember before, this is the form of the solution set. So it begins with S equals braces, and we have two solutions, which is negative 7 and 7. That's how you do first alternative. How about the second alternative? We are speaking still the same equation. Okay. The second alternative is I'm using addition property of equality. Don't forget, addition property of equality means that when you add the left member with a number or a variable, you will applicate the same to the right member. So Since the original equation is this, x squared minus 49 equals 0, I will try to get rid of negative 49. It becomes 0 by adding with its additive inverse. Okay, so I will add both member. This is the addition of property of equality. I add the left member by 49, so I have to do the same with the right member. Add with by 49. Okay, so don't forget you need to applicate the same. Okay, fair, since you cannot change the value of at one of the side. Now after I do this, let me just simplify. Okay, it's obviously 0 and this one obviously 49, right? So this is the next statement, x squared minus equals 49. This is the equation. And then how to find the value of x? I square root it. But you have to remember about squaring things. If you are squaring things like this statement, you need to present both positive and negative. Okay, so this is the statement. Square root the left side, it means I have to square root also the right member. By square rooting x squared, the square root cancel the square. But the right side, by square rooting 49, you have to include plus and minus there. Okay, and then I simplify. So I will have x equals plus 7 and negative 7. Plus 7 and negative 7. That's how you read it. Okay. So yeah, before I go to that, so I need to write down the solution set. It's the same. Okay, I forget that. So yeah, we still have the same. We have to have the same solution by any approach if you do it correctly. Okay, so in math, of course, we avoid any ambiguity. We need to present the same result, even if you are doing a different approach. So the next one, example 2, if you're given this equation, okay, again, this equation contains two expressions on the left member and on the right member. Okay, so what we should do with an equation, you need to find all possible values of x, all possible numbers that replace x to make this equation true. It means this one must be equals this one. Okay, now I will offer you two alternatives again, okay, for solving this. The first one, using a very conventional, and you need to avoid this one. So actually, by concept, you need to do just trial and error. I just do the trial and error, okay, to find all possible values to replace your x to make this one is true. But can you imagine how difficult this is? So first, yeah, you can for example, I will just choose one. Okay, so I will check one. One is the possible values or possible solution for your equation here. So you just substitute it. So by substituting it, I will just substitute this is and this by 1. So it becomes 2 times 1 minus 5 equals 5 plus 2 times 1 minus 3. Okay, so I substitute x by 1 and I will check whether this equation is true or false. Okay, by doing arithmetic, you can see that it is negative 1 and 1, so it's false. It means 1 is not one of the solution for your equation. Okay, and then you will go further by another candidates. Okay, but can you imagine that we have many candidates, not just 1, 2, 3. We have negative also, we have decimals also. We can also check how if a radical number, a transcendental number. So it will be an endless work for you. That's why trial and error is not the way, is not the method that is suggested. If for some of you doing this previously, it's because we have a simple equation, but stop doing that now. Okay, so instead let's use algebra. Okay, so first, from this original equation, the first thing that I will do is I use the distributivity axiom. Okay, I distribute 2 into this parenthesis. So by doing that, I will have this statement. Okay, next, after I have this, I will use the definition of subtraction. So we have to simplify the right member by using the definition of subtraction. I just want to show you how the commutative work. So by using definition of subtraction, actually I will translate this to x minus 6 into addition to x plus negative 6. Okay, and then I will use the commutativity for addition. Okay, I will commute this and this, the second and the third term of your right member. Okay, and then I will do the arithmetic since 5 plus negative 6 can be calculated. Okay, so I have this as my next statement. And then what? After this, I cannot simplify the left member. I cannot simplify the right member. So the next thing is to solve for x, I need to make x exclusive. So let's use addition property of equality. Okay, I will add both sides by, or subtract both sides by negative 2x. Okay, when I subtract the left member by negative 2x, by 2x, sorry. So you have to do the same with the right member. That's how equation works. Okay, addition property of equality. And then I will collect the same or like terms. Okay, that is the last step that we will do. And this is the last statement that we cannot do anything about it. Negative 5 equals negative 1. And this statement is false. And you cannot go further. So what does it mean? It means that you have no solution. And you can write it this way. If you have no solution, you can write it this way or this way. You can choose one. Okay, it means if you are using the first method, you will be frustrated since you will use or you will try to substitute x by any numbers, and in the end it was just not proven the solution. Okay, so that's why we cannot do the first approach. Okay, let's do the second approach step by step. I have already provided you with the name. This is example 3. So if you're given this equation, again, you have to know the objective. You need to find all possible values that can replace your x to make this equation true. Okay, so how to solve x? The first thing that you need to do is you exclude x. Okay, by solving x, you need to exclude x. So let me show you step by steps how to exclude x from this original equation. The first thing I want to get rid is the x from the right member. Since I want to exclude x, it means I need to collect all of the x into one member, one side. So I want to just eliminate this x, okay, by subtracting it or adding it with its additive inverse, okay, to make it 0. Don't forget additive inverse. The objective is to make it 0. So by adding or subtract something on the right member, you need to do the same as well to the left member. Okay, so let me just show you the steps. We use addition property of equality. I add something on the right side, I add something on the left side. So for this one, I subtract the right member by x. Why? My objective is to get rid of this one. Okay, but I have to do the same with the left member. Okay, so I'm using the definition of subtraction also here, and then commutative property of addition. So but let me just, of course you have understood this, so I will skip that steps and I will just go directly to collecting like terms, since we have this and this as like terms on the left member. This and this are like terms on the right member. when I collect them, 5 minus x becomes 4x, x minus x becomes 0. Okay, I hope you can understand this. This is the result of collecting like terms. And then you can see that the x is still not exclusive. It's still accompanied by 4 as as multiplier and subtracted by 2. So let's just get rid of that. So first I will get rid negative 2 here. Okay, by another addition property of equality. I will add it with its additive inverse. So I will add by 2. Since I add by 2 on the left member, I have to apply the same on the right member, right? So in the end, by doing arithmetic, I will have 4x equals 9. Okay, I'm still have the x not exclusive. There's still 4 as its multiplier. So how to get rid of 4? It is by multiplied with its multiplication inverse. No, I'm sorry, multiplied by multiplicative inverse. Okay, so I'm doing multiplication property of equality. Means when I multiply or divide something on the left member, I have to do the same on the right member. So when I multiply the left member by 1/4, the objective is to get rid 4 here. I have to do the same on the right member, right? So in the end, by doing arithmetic, I will have that x will be equal to 9/4. Okay, I hope that this is clear. And we have already had the solution since the x has already been exclusive. Okay, so after you find by doing arithmetic, you have one possible value of your x. Okay, you can be certain there will be no other values of x. Okay, if you do it correctly. So don't forget you have to do it with the solution set form. The conclusion is the solution set or the bucket of your solutions will contains only one possible answer, which is 9/4. You can write 9/4. You can use it in a mixed number. Okay, like you can use it in decimals. For example, 2.25. It's okay as long as it represents the same value. That is example 3.